So here we want to discuss the general idea of supply and demand. We're not going to go too deep into this topic, but just talk about a general idea of how supply and demand work. First of all, we're going to define a few things. We're going to let X represent the number of units of a commodity, and P will represent the unit price of that commodity. So unit price being the key word there. Since X and P, of course, we cannot sell a negative number of units and we don't have a negative price. They're going to be non-negative values, and we're going to be working basically in quadrant 1. So we're going to analyze these ideas using a graph. So here I have quadrant 1 graphed, and we're going to let X represent the units demanded, and I'm going to put the demand along the traditional X-axis here. And we're going to let unit price be the traditional y-axis here. So this is going to be P. Okay. So in general, the quantity demanded of a commodity decreases as the unit price increases, and vice versa. So for example, let's say that I am selling some pencils, and I would like to sell each of these pencils for $50 each. All right, these are really nice pencils. How many pencils would you be inclined to buy? Well, that price is pretty high. And the higher the price, so let's say that I have a high price, the lower the demand. So you might be likely to only buy one of those pencils. So here's the idea. If I charge a high price, then there will be low demand. It's just a generalized statement. If I decrease the price of the pencils, let's say that I choose to sell them for only 50 cents each, if I lower the price, then you are more inclined to buy more pencils. You might buy 10 pencils and keep a few as backups. So if I have a low price, then there's going to be higher demand. So you're going to demand more product. Okay, so low price, higher demand. Okay, so I plotted a few points to kind of represent these ideas. But what we see is that we end up with what we call a decreasing function. Okay, so demand increases. So as demand increases, the price decreases. Or you could think of it like this. As the price decreases, then demand will increase. So we end up with what we call a decreasing function that represents our demand curve. All right. Let's contrast this with the idea of a supply curve. In general, an increase in the commodity's unit price increases or induces the producer to increase the supply of a certain commodity. So we're going to let X represent the number of units supplied. So this time we're going to take the perspective not of the consumer, not of the person that's going to be buying these products, but of the manufacturer, the person that's going to be supplying these products. So I'm going to label my axis again. Low supply, high supply, low price, and then higher price. So here's the idea on the other end, on the other side of the idea of supply. If I know that I can sell something for a lot of money, then I'm more inclined to actually produce this object, produce these units. So if I know that I can charge a good price and make a lot of money, then I'm more apt to make more product. So in this case, I would say high supply or high price, high supply. So I'm willing to supply more or make more of that product if I can charge a higher price. In theory, I would be able to make more money in that case. If I can only charge a very low price, or if the amount of money that I will be making off this product is very low, then I'm not motivated to make very much of this product. So low price, low supply. And the idea here is that now I have an increasing function. Okay, so it's an increasing function. So supply increases as price increases. So they increase at the same time. So we call the supply function a increasing function. Okay, so this is just a general theory of the ideas behind supply and demand. So now we're going to look at a few examples of supply and demand. We're going to kind of confirm what we talked about a little bit earlier. For the following demand equations, X represents the quantity demanded in units of 1,000. I'm going to underline that. That's going to be significant to our problem. And P represents the unit price in dollars. We want to sketch the demand curve. We want to determine the quantity demanded when the unit price is set to be P equals $11. So we're going to graph this value. We're going to graph this equation where X represents what we're putting in and P represents what's coming out. So remember, P represents kind of that traditional y-axis and X is representing the traditional x-axis. Alright, so we said that X cannot be negative, so we're going to start with potentially 0 units. Then we're going to go up from there. So we're going to go 1, 2, 3, 4, 5, 6. We're going to go on as far as we can there, keeping in mind that these represent thousands of units. Okay, so I'm going to label my axis 0, 1, 2, 3, 4, 5, 6, and so on. Alright, let's see what p-values we get out. So if x is equal to 0, then we can see that if we plug in a 0 in place of x there, then we're going to get 36. If we put an x value of 1 into the function, so let's actually do this right here on the side. One thing that you want to be careful about is that when you plug this value into the function, the negative is not included as part of the squaring. So it's first thing you want to do is put parentheses everywhere you have an x, and any other operations that are outside of x, you want to put those outside of the parentheses. So when we put 1 in, we get 1 squared, which is 1. The negative comes down, and then we end up with 35. So be careful with your order of operations and what your exponents apply to. When a 2 goes in, let's see what we get for that. Just going to use my same setup here. So we put 2 in, we get -4, which gives us a positive 32. And I'm going to keep using that same function. If x is equal to 3, then I get 27. If x is equal to 4, then I get 20. Then I get 11. If x equals 5, and if x equals 6, we end up getting out 0. Alright, so I'm going to graph the points that I have so far. Before we do that, let's label the p-axis or the y-axis here. I'm going to go ahead and label in units of 5. So that's 0, 5, 10, 15, 20, 25, 30, 35, and we're going to plot some points. All right, let's label our points. So we have 0, 36, which is about right there. We have 1, 35, which is about right there. 2, 32, about right there. 3, 27. See 4, 20, 5, 11, 6, 0. Right, I'm going to connect all of these points. And one thing we want to observe here is that we do get a decreasing function. So we're talking about unit price and demand. So the higher the price, the lower the demand. The lower the price, we see the higher the demand. So our question was, what is the demand if P is equal to $11? So if we know that the unit price, P, equals $11, we want to know what is the X value. Now we can actually see this right on our graph. If P is equal to 11, then X is equal to 5. And remember that this represents units of 1,000. So P is equal to, or X is equal to 5,000. So we end up actually saying that if the unit price is $11, then there will be 5,000 units of this particular product demanded. Let's say that we didn't have that point on our graph. How could we figure that out? Well, we could set P value in your original equation equal to 11, and then we could solve for X. So let's just see how we would go about that if we didn't actually have that value on our graph. So I would subtract, let's say I subtract 36 from both sides. We want to get X alone. That would give me negative 25 is equal to negative X squared. Divide both sides by negative 1, and that makes both sides positive. And then lastly, take the square root of both sides. So technically we get that X is equal to plus or minus 5, but we've talked about that X can't be negative, so we discard the negative result and we get X is equal to 5. So if you didn't have that 11 on your chart so that you could find that X value, you can always plug in a p-value 11 or whatever the p-value is into the original function and then solve for X. Alright, I want to make note of this before we go on to the next problem. It says here that we make sure to give our answer correct to the nearest full unit. So we will take that into account as we go into the next problem. Alright, so here we are given the demand function P is equal to the square root of 18 minus X squared. And we're asked if the price is $2, then what is the quantity demanded? Okay. So once again, we're going to make a table for our P values. So this is going to be P, this is going to be X. And X can't be negative, so the smallest value that we can plug in would be 0. And I'm going to go up from there. So I'm going to label 1, 2, 3, 4, 5, so on. And let's find out what these values give us. So let's plug in. P is equal to the square root of 18 minus X squared. So remember, once again, the negative is not included as part of the squaring. So if we plug in a 0 in place of X, we end up getting the square root of 18. And let's put that into our calculators to find an approximation. I get approximately $4.24 as my unit price. Alright, if we put in a 1, let's put in a 1 there, we get 18 minus 1, so that's the square root of 17, which gives us an approximate value of a little bit less than 4, a little bit more than 4, so 4.12, so $4.12. If we put in a 2, that's 18 minus 2 squared, so that's 18 minus 4. That's the square root of 14, which gives us about 3.74 in our calculators, kind of finding an approximation there. If X is equal to 3, let's visualize that. If X is equal to 3, we get something really pretty nice. So that's really 3 squared, which is 9, so 18 minus 9 would be 9. The square root of 9 is just 3, so that's really nice. We put in a 4, that's minus 16, so that's the square root of 2, which gives me about 1.40, so $1.40. If we put in a 5, let's be careful about that. If we put in a 5 and I square it, that's 18 minus 25, which gives me the square root of negative 7, which is not possible. That's an imaginary value, and we're not allowed to have those values. So 5 and 6 are too big to put into the function. So let's go through and label. Now this time my p-values are pretty small, so I will label just in units of 1. Right. So if X is equal to 0, then P is equal to a little bit more than 4. If X is equal to 1, once again we're a little bit more than 4. For 2, we're a little bit less than 4. so 3.74 approximately. 3, we get 3, which is pretty nice. 4, I get 1.40, so about halfway between 1 and 2. And so we can see that we're curving down in a little, looks like a little semicircle, something like that. Okay, so we definitely have a decreasing function once again, and we are asked to find out what is the x value if the unit price is 2. So this time, p value of 2 is not actually on our graph. It's not in our table, so how do we solve for that p value, or that x value? So this time we're going to take that p value of 2 and we're going to plug it in place of p in our original function. And we're going to solve for what x has to be in order to make that true. So I'm going to square both sides to get rid of that square root. We get 4 is equal to 18 minus x squared. Alright, I'm going to subtract 18 from both sides. I get negative 14 equals negative square root of x squared. Once again, I'm going to divide both sides by negative 1, and that makes both sides positive. And the last thing I want to do to solve for x is take the square root of both sides. So technically I get plus or minus square root of 14 is equal to x, but we said that x can't be negative, so we're only taking the positive square root of 14. And so we're told basically that x represents an approximate value here. So let's write out what that x value is. So that's x is equal to, and I'm not going to round here, we're going to be careful of something. We know that x represents thousands of units. So I'm going to be careful about how I round here. So in my calculator, square root of 14 gives me 3.7416573. So we said earlier, we made note that we're asked to round x to the nearest full unit. So we're going to be careful about something. Not to the nearest thousands of units, but to the nearest unit. So in this case, since x represents thousands of units, I'm going to find out what this value represents in my calculator, and then I'm going to go ahead and I'm going to multiply by 1,000. I'm going to move my decimal place 3 spaces to the right. So then what I actually get is 3,700,401.6. So now my decimal place is here. I want to round to the nearest full unit, so that means I'm going to round up from 1 to 2. So we're going to say that the quantity demanded, rounded to the nearest full unit, would be 3,742 whole units demanded. Okay. So keep in mind that x represents thousands of units. So you want to be careful when you round. If it says round to the nearest whole unit, we're going to first of all write in the actual quantity of units. So we're going to go to the thousands, multiply by 1,000, basically move your decimal place 3 spaces to the right, and then use this number right after the decimal to decide, do I need to round this nearest unit up, or does it stay the same? So in this case, you round it up. So 3,742 whole units demanded when our unit price is $2. All right, in example 6, we're given a supply equation. So x represents the quantity supplied of a unit, and it's in units of 1,000. And p is the unit price given in dollars. So we're asked to sketch the supply curve, determine the price at which the supplier will make 2,000 units of a commodity available in the market. Alright, so we're going to sketch our curve. Okay, we're going to start with 0, and then we're going to go up from there. Okay, if x is equal to 0, then what is p? So that's a pretty easy value to find. 0 cubed is 0, plus 0, we get 10. 1 is also pretty easy. 1 cubed is 1, plus 1. So that gives me 12. As we go on from there, things get a little bit more interesting. So let's write out what we're actually going to be doing. So we're going to take 2, we're going to cube it, then add 2, and then add 10. So we get 8 plus 2 plus 10, so I get 20. Okay, we're going to do the same thing for 3 and 4. I get 3 for 3, I get 40. For 4, I get 78. And so we can see what's happening here. My values are increasing. I'm going to stop right there and just start to graph my supply curve. X represents now units supplied. So we have 0, 1, 2, 3, 4, 5. And my t-value here, my p-value, I mean, let's label in units of 10. So 0, 10, 20, 30, 40, and so on. So we can see what's happening here. When we plug in a 0 in place of x for p, we get 10. We plug in a 1, we get 12. For 2, we get 20. And we can see that our curve is going up. Oops, so this is supposed to be 40. Okay, so when x equals 3, then p equals 40. So we can see what's happening here. We have an increasing function for our supply equation. Okay, I'm just going to stop right there. We have a good idea of what that looks like. So the last thing that we're asked to do once we visualized our supply curve is to determine the price at which the supplier will make 2,000 units of the commodity available in the market. So we want to be careful about something. We're talking about 2,000 units supplied. X is given in a quantity of 1,000 units. So what we're really looking at then is when x equals 2, then what is the price? So determine the price, the unit price, at which the supplier will be willing to produce 2,000 units of this commodity. So first of all, you want to be careful about something. X is equal to 2. Remember, this represents thousands. So x is 2,000. So we want to solve for p. Now this is actually pretty nice. We've actually already solved this. We said if x is equal to 2, then p is equal to 20. So if the unit price is $20, then the supplier will be willing to provide 2,000 units to the market.